Africa, a continent of diverse landscapes and rich biodiversity, faces a growing crisis: plastic waste. From the vast savannas to the dense rainforests, no corner of this beautiful land is untouched by the scourge of plastic pollution. Every year, millions of tons of plastic end up in landfills, clog rivers, and pollute the ocean. This relentless influx of plastic waste is not just an eyesore, it disrupts the delicate balance of nature and poses a severe threat to marine and terrestrial life. This waste threatens wildlife, ecosystems, and human health. Animals often mistake plastic for food, leading to fatal consequences. The toxic chemicals released from degrading plastics seep into the soil and water, contaminating the food chain and affecting human communities. In many African nations, waste management systems struggle to keep pace with rapid population growth and urbanization. The infrastructure is often inadequate, leading to overfilled waste sites and uncollected garbage piling up in urban areas. This leads to plastic accumulating in the environment, where it can take hundreds of years to decompose. The long-lasting nature of plastic means that the waste we produce today will linger for generations, continuing to harm the environment and wildlife. The sight of plastic bags caught in trees or bottles bobbing in rivers is sadly becoming commonplace. These images are a stark reminder of the pervasive nature of plastic pollution and its far-reaching impacts. This plastic waste represents a loss of valuable resources and a threat to the continent's future. The economic cost of managing plastic waste is enormous, and the environmental damage is incalculable. If left unchecked, plastic pollution could undermine the progress and development of African nations. However, amidst this challenge, a glimmer of hope emerges from a surprising source: tiny worms with an unusual appetite. These worms have shown the ability to break down certain types of plastic, offering a potential solution to the plastic waste problem. Innovative approaches like this give hope that with concerted effort and creativity, we can turn the tide on plastic pollution and protect Africa's natural heritage for future generations. Deep within the heart of Africa, researchers have discovered several species of worms with an extraordinary ability. They can eat plastic. These are not your everyday earthworms, but rather specialized creatures with a unique digestive system. These worms, including the larvae of certain beetles and moths, possess enzymes that allow them to break down the complex chemical bonds in plastic polymers. This discovery has sparked excitement among scientists and environmentalists alike, offering a potential solution to the plastic pollution crisis. These worms could hold the key to developing innovative and sustainable waste management solutions. Imagine a world where plastic is no longer a persistent pollutant but rather a source of food for these remarkable creatures. The secret to the plastic-eating abilities of these worms lies in their gut bacteria. These microorganisms produce enzymes that break down the long chains of molecules that make up plastic polymers, such as polyethylene, one of the most common types of plastic. This process essentially digests the plastic, converting it into organic material and simpler compounds. Some worm species can even degrade polystyrene, a particularly problematic plastic that is notoriously difficult to recycle. This discovery has opened up new avenues for research, with scientists working to understand the complex biochemical processes involved. The goal is to harness these natural processes to develop efficient and scalable methods for plastic degradation. Numerous scientific studies have confirmed the plastic-eating abilities of these worms. Researchers have documented the worm's ability to consume and break down various types of plastic, analyzing the chemical composition of the ingested and excreted materials. These studies provide compelling evidence that these worms can effectively degrade plastic, offering a potential solution to this global environmental challenge. For instance, a study published in the journal Environmental Science and Technology found that the larvae of the wax moth, Galleria melanella, could consume and biodegrade polyethylene at a remarkable rate. This groundbreaking research suggests that these worms could be utilized to manage plastic waste and reduce its accumulation in the environment. Section 5. A brighter future? Benefits of worm-based waste management. The potential benefits of using plastic-eating worms for waste management are significant. First and foremost, these worms offer a natural and eco-friendly alternative to traditional plastic disposal methods, such as landfilling and incineration. By breaking down plastic into organic matter, these worms can help reduce the amount of plastic waste that ends up polluting the environment. Moreover, The byproducts of worm digestion, such as compost, can be used as fertilizer, enriching the soil and promoting plant growth. This creates a circular economy where plastic waste is transformed into a valuable resource. This approach aligns with the principles of sustainability, reducing waste and promoting environmental health. Section 6. The hurdles to overcome, challenges and limitations. While the prospect of plastic-eating worms is promising, some challenges and limitations need to be addressed. One challenge is the scalability of worm-based waste management systems. While effective on a smaller scale, scaling up these systems to handle the vast quantities of plastic waste generated globally requires significant infrastructure and resources. Another limitation is the specific dietary requirements of these worms. While they can consume plastic, it is not their sole source of nutrition. Researchers are working to optimize the worm's diet and environmental conditions to enhance their plastic-degrading abilities. Further research and development are crucial to unlocking the full potential of this technology. Section 7. Scaling up for impact, from lab to landfill. To harness the full potential of plastic-eating worms for waste management, researchers are exploring ways to scale up their operations. This involves not just understanding the biology of these remarkable creatures, but also engineering the right environments for them to thrive. Scientists are meticulously studying the worms' dietary needs, their breeding patterns, and the specific conditions under which they can most effectively break down plastic. Creating optimal conditions for the worms to thrive and efficiently break down plastic is a complex task. It requires a deep understanding of the worm's natural habitat and behavior. Researchers are experimenting with different types of plastic, varying levels of humidity, temperature, and even the composition of the soil or compost in which the worms are placed. The goal is to create a controlled environment that maximizes the worm's plastic-degrading capabilities. Pilot projects are underway to test the feasibility of large-scale worm composting facilities. These pilot projects are crucial for understanding the practical challenges and potential solutions for scaling up. They provide valuable data on the efficiency of the worms in different settings, and help identify any unforeseen issues that might arise when moving from a laboratory setting to a larger, more industrial scale. These facilities would function like giant composting systems, where plastic waste is fed to the worms under controlled conditions. The process involves sophisticated machinery to shred and distribute the plastic waste evenly, ensuring that the worms have constant access to their food source. This setup mimics natural composting processes, but on a much larger scale, designed to handle the vast amounts of plastic waste generated by modern society. The worms would then break down the plastic, producing compost as a valuable byproduct. This compost can be used to enrich soil, promoting healthier plant growth, and contributing to sustainable agricultural practices. The transformation of plastic waste into compost not only addresses the issue of plastic pollution, but also creates a circular economy where waste is turned into a resource. While still in the early stages, these initiatives offer a glimpse into a future where plastic waste is no longer a threat but a resource. The vision is to create a sustainable system where plastic waste is continuously recycled and repurposed, reducing the environmental impact and conserving natural resources. Researchers are optimistic that with continued innovation and collaboration, this vision can become a reality, transforming our approach to waste management and environmental conservation. Section 8, a global solution, inspired by Africa. The discovery of plastic-eating worms in Africa has global implications. As the world grapples with the plastic waste crisis, solutions inspired by nature offer a beacon of hope. This discovery highlights the importance of biodiversity and the potential of nature to provide solutions to human-made problems. By sharing knowledge and collaborating on research, we can accelerate the development and implementation of worm-based waste management solutions worldwide. This global effort requires collaboration between scientists, policymakers, and communities to create a more sustainable future. Section 9, a hopeful future towards a world without plastic waste. In recent years, the global community has become increasingly aware of the devastating impact of plastic waste on our environment. From oceans filled with plastic debris to landfills overflowing with non-biodegradable materials, the need for innovative solutions has never been more urgent. The discovery of plastic-eating worms offers a glimmer of hope in the fight against plastic pollution. These remarkable creatures have the ability to break down plastic materials, turning them into simpler, biodegradable compounds. This breakthrough has the potential to significantly reduce the amount of plastic waste that ends up in our ecosystems. While challenges remain in terms of scalability and optimization, the potential of these creatures to revolutionize waste management is undeniable. Scientists are working tirelessly to understand the mechanisms behind the worm's plastic-degrading abilities and to develop methods to harness this natural process on a larger scale. The goal is to create efficient and sustainable systems that can be implemented globally. This discovery serves as a powerful reminder that solutions to even the most daunting environmental challenges can be found in the most unexpected places. Nature, with its incredible diversity and adaptability, often holds the key to solving problems that seem insurmountable. By studying and mimicking natural processes, we can develop innovative technologies that work in harmony with the environment. By embracing innovation, investing in research, and working together, we can harness the power of nature to create a cleaner, healthier, and more sustainable future for generations to come. Community involvement and education are also crucial in this endeavor. By raising awareness and encouraging sustainable practices, we can inspire individuals and communities to take action and make a difference. The journey towards a world without plastic waste starts with a single step, and perhaps a single worm. Each small action, whether it's reducing plastic use, supporting research, or participating in cleanup efforts, contributes to a larger movement towards a sustainable future. Together we can create a world where plastic waste is a thing of the past, and our planet can thrive once again.